very much for the presenters. And the next article that will be presented is number 154, which is the title To Action Vehicle Routing Problem to Disaster Mapping Process Using Cooperated Vehicle Assignment from uh, authors Perwira Redi, Perhamaya. Then
Yes, yes.
I give the floor to your presentations. Now
Thank,
it's your turn.
thank
Thank you.
you, Achan. I think, as if I'm not mistaken, the last time I meet Achan Rapipan is either last time ICLS in Taiwan or previous APMs in Taiwan. And yeah, it is very nice to meet you again, Professor Pitakaso. I learned a lot from your paper, from your a lot of from GA and meta heuristic stuff from your publications. So in today's presentation, thank you also the committee for letting us to give for the time to sharing. Greetings everyone. Here my name is Agung Ngurah Perwira Redi. People used to call me Wira, and I would like to present our it's actually ongoing research on basically it's a variance of vehicle routing problem, but we applied it when it's collaborated within drone application to do the mapping during disaster planning, disaster management activities, and that this gonna be our presentation today, and it's a collaborative research between BINUS University, which the place I'm teaching, and Universitas Pertamina and Universitas Gajah Mada. So the presentation will be divided into 4 parts: background, methodology, result and discussion, and conclusion and future research directions. So for the start, I would like to start from a little bit of data and the background why we conduct this research. So basically, if you know Indonesia, we geographically can be said as the one of the most how to say high risk natural disaster country. This data perhaps can give you a little bit of perception on how we need to really deal with this natural disaster event in Indonesia. Well, we know 2020 is COVID years, right? But beside COVID, actually Indonesia also has several natural disaster events, and it's quite a lot. As you can see, this data: tornado, flood, landslide, bushfire, drought, volcano eruption, high tide, earthquake, and so on. Okay, so yeah, of course, we our research will not dealing with all those natural disaster event. We're focusing on one particular event first, like flood, because it's one of the mostly occurs, and it occurs like every season, rainy season. There must be flood somewhere in Indonesia. But one of the characteristic of disaster is that when you have a disaster, it's always uncertain. We don't want it, but it somehow happens. It's in an unpredicted time. So the nature of it is that all of the data related to the disaster, the condition, the environment will be changing time to time. So we need a proper information to conduct our action on how we can relieve those people or area affected by this disaster. So data is one of the important things. Another is like one particular data is the map of the area affected by the disaster. So in order to get the mapping data, so we are talking about the post-disaster assessment. It's not before, but post. So after the disaster happened, we need to have a map, a very informative and up-to-date mapping. So there are two ways. First is using satellite data, in which of course it will be like up to date, but sometimes to get those data we need to have a particular system ready, and then it's not cheap. It's not cheap also, Meanwhile, there is another approach which is now trending nowadays, using drone, and I'm not talking about the big and then high coverage drone, but the commercial one, the one that now every day I think many and more people are using it right now, have it in their home. So we even have a lot of drone community that is currently trending. So why don't we take advantage of those trends, and then we can ask them to help whenever the disaster happen, like NGO that provide those drones to help the mapping activities for disaster. Okay, so as an operation research a researcher in the field of operation research, so we can see that if we want to utilize this resource well, so we can actually treat this as an optimization problem. So since the drone itself has limited capacity, like they can only coverage not much area, even though we can like always have a backup battery, but again, it's not really like the big and high coverage drone that perhaps much more expensive. So we combine those approach with the utilization of ground vehicle. It can be trucks, it can be car, but perhaps for Indonesian landscape, one of the most suitable ground vehicle to be considered is motorcycles. So here we try to create a model based on this condition, where we see that okay, this will be a 2 echelon networks optimization. The first echelon will consider how we create the best and efficient route for the motorcycle itself to like perhaps park in the spot where we can start launch our drone. We call it the mapping point. And then from that area, of course, that will be enough for the drone to coverage the mapping area, in which will be the area impacted by the disaster. So here is our the way we see these problems, and we create a mathematical optimization model, so-called the 2 echelon VRP with mapping operation drone, and for mapping operation with drone, something like that. So basically we use motorcycle and drone, and the collaborative itself, basically we extend from our previous research, in which we simplified the model itself into the first echelon is a routing problem, and the second echelon is an assignment problem. But after further discussion with the drone community expert that have understood the mechanism on how the mapping works, actually it can be done more efficiently while we can where we can treat the drone itself not as a assignment problem, but also as a routing problem. Since sometimes the mapping area is not really large enough, so the drone itself can be assigned as a routing, how to say, they have a routing mechanism itself, so we can assign them like that. Okay, and then there we basically extend from our previous models, in which now we are not only considering routing in the first echelon, in which for the ground vehicle or the motorcycles, but we also consider routing for the drone itself, where after they arrive, or we select the place to launch those drones, and then we create another routing mechanism in parallel with the decision of the routing in the first echelon. I'm not going to be in detail in this one, but basically what we consider as the objective value, it might be different with the most of the vehicle routing problem with drone in the field of commercial application. So basically, this model also, inspired by a lot of models that already published in the area which has the drone application in it. But most of them is considering the application in the commercial side. So basically, we will try to minimize the cost and so on and so on. Okay, but here, since we are doing the operation for humanitarian perspective, so it might be a little bit different. Instead of the cost itself, we are trying to optimize those resources to minimize the operation time. So the operation time of this mapping activity should be fast, because the faster we get the mapping data, the newest information, the more relevant information, the better we can act on the disaster event. Okay, so basically it consists of we consider three basic time that will consume in this activity. First is the routing time in the first echelon. Second is the routing time is in the second echelon done by the drone. And then the third is the mapping time. So whenever it's visit the mapping area, so the drone need to conduct their mapping activity, and it takes a lot of resources on their time for that to do the mapping itself. And I think the time is quite limited here, so I guess the constraint itself, I need to explain this a little bit. So one of the most significant constraint limit this model is the consideration of that the drone itself has its limited capacity, and the the ground vehicle itself also have limited capacity on their fuel. Okay, perhaps that like that. And then we need to restrict that. Yeah, it's basically, since it's inspired the vehicle routing problems. So basically, most of these constraint or model formulation on the constraint is adopted from those VRP models. Okay, here, after those models being well developed, we create, we try to implement those in the somewhat simulated event on flood. But wait, sorry, this is this one, the flood. Since we are now working with our college in UGM, they are close to the area where there's volcano eruption happened in the recent years. So we are using those data to be experimented with. So it's more close with the data that we have earlier. And so the flood data here in Bekasi city is the one that happened in January 2020. So this data, basically, my student live near the area, so they can collect the quite relevant data on that particular site. And all these particular parameters being taken from the relevant website, from the drone itself until the motorcycle speed and so on. So and then we experimented using a commercial mathematical programming solvers called AMPLs, and it provide quite powerful solver for solving those mathematical formulation, so-called Gurobi. And so basically, what we plan to do in this early research is that we just want to verify whether our formulation in that models is turn out to be correct or not. So basically, after we conduct from those data, we separate into several smaller data. Basically, we cluster it in those several smaller mapping point and stopover point. And we evaluate in detail the route for the first echelon and second echelon, and we see that there is no route is violating any constraints. So well, we cannot provide yet comparison with whether this route is good or not, or any other further analysis, because basically what we want to see here is that, okay, the route is visible, and then we can move on to the next phase of the research, in which, so after we have these models, we will move on to, okay, what if we solve a larger data, like what I mentioned earlier, the volcano data provided by our college in UGM in Yogyakarta. That's gonna be take a lot of more points, and we already try with our flood data actually, but up until if I'm not mistaken, 20 or 30 nodes, the solver already taking so long, even until like running for 3 hours. We let the solver run there, and then it's not give any visible result yet. So I guess that we are going to move to first solve larger data, of course, and then we will try to adapt several meta-heuristics algorithms to see whether it can solve this efficiently or not. And I'm hoping for a good discussion and suggestion or comments from peer and college here in from ICLS and panels. So I think that's all from our presentation. Thank you very much. I will return the session back to our session chair, Professor Rapipan.
Thank you very much.
Yeah.
Actually, it's very up-to-date topics because now Thailand have floodings a lot from the depression. It's have 2 to 3 depression now come to Thailand, and some provinces have severe flooding, and it would be nice to use the model to both of combination of the vehicle type, like motorcycle, that is also have a lot in Thailand too, and also the community drone is also effective way to solve the problem, like the flooding or some other area that you cannot go with the normal vehicle. That's great jobs.
Thank
you. And do you plan to do something like heuristic or meta-heuristics after this model, or
Yes.
or you are ongoing?
Yes, we are currently implementing, including several that perhaps from your paper also, like the GA that you proposed earlier. Then, but we are currently trying tabu search and simulated annealing approach. Since we have several framework already done, so we can try plug and play it for these models.
Okay. The local set type of heuristic is matched with the vehicle routing problem. Actually, it would be great to apply tabu search and some like a local set basic meta-heuristic. It would be great. Thank you very much for the presenter, and see you in Thailand next year. Thailand will be the host of ICLS next year.
Okay, great. Thank you, Professor Rapipan.
Okay, thank you very much. For the last presenters, is the paper ID